So, welcome to the Security Architecture Model Practice Lab. In this module, you will be provided with the instructions and devices needed to develop your hands-on skills. Virtualization and containerization are architecture models important to security. They provided efficient resources, utilization probability, rapid deployment, flexibility, and scalability. In this module, you will install the Ubuntu VM in the Hyper-V hypervisor and use Docker to create and manage containers in a command line environment. And Portainer to create and manage um, container through a browser's base graphical user interface. So learning outcome. In this module, you will complete the following exercise. Exercise 1, create a VM, use containers, and lastly, exercise 3, complete VM deployment. After completing this module, you should be able to create a VM in Hyper-V, launch Ubuntu installation, create and manage containers from a CLI, create and manage containers from GUI, manually relaunch the Ubuntu VM, test the new VM. So exam objectives. The following exam objectives are covered in this module. Explain the purpose of medication techniques used to secure enterprise segmentation. Then compare and contrast security applications of different architecture models, architecture and infrastructure concepts. Consideration, lab duration, it will take approximately 1 hour to complete this lab. So it will take approximately 1 hour to complete this lab. So click next. So lab topology. During your session, you will have access to the following lab configuration. So depending on the exercise, you may or may not use all of the devices, but they are shown here in the layout to get an overall understanding of the topology of the lab. So ACI DC01, ACI DM01, ACI Win11, ACI Alma, and ACI Kali. So click next. So exercise 1, create a VM. A virtual machine requires a hypervisor to manage it. In this lab, ACI Win 11 has Hyper-V installed. Hyper-V enables the creation and management of VMs on Windows-based system. Hyper-V is considered a Type 1 hypervisor, meaning it runs directly on the machine hardware, not through the operating system. Type 1 hypervisor are also known as bare metal hypervisors. The Hyper-V appears to be an application on the Windows 11 operating system. It boots up before the Windows OS and runs as a GES OS, enabling it VMs to communicate directly to machine hardware and making it a Type 1 hypervisor. In this exercise, you will create a VM with Hyper-V and begin the VM installation. So learning outcomes. After completing this exercise, you should be able to create a VM in a Hyper-V, launch Ubuntu installation. So your devices, you will be using the following devices in this lab. Please power this on now. So ACI DC01 and ACI Win11. So in the VM or task 1, create a VM in Hyper-V. To create a VM, an installation file is required. In this lab, an Ubuntu VM ISO file has been downloaded and is stored in the ACI Win11 folder. On this task, you will create a VM in Hyper-V and configure the Hyper-V store for VM installation. So step 1, on the taskbar, select so the taskbar, select Hyper-V Manager. So Hyper-V Manager in the actions pane, select New, then select Virtual Machine. So in the new virtual machine wizard before you begin page, click Next. Then in the name, that's gonna be Ubuntu 22.04.3. Then click Next. The new virtual machine generation 2. Select the radio button next to the Generation 2, then click Next. Generation 1 VMS provide compatibility with older operating system by emulating legacy hardware components. Generation 2 VMs are suited for more modern operating system and include UEFI firmware as opposed to BIOS in Generation 1 VMs. Additionally, Generation 2 VMs have more security feature and a better overall performance than Generation 1 VM. So type the following in the startup memory field 2048. Then select default switch from the connection drop down. Note, connecting the VM to the default switch will allow it to communicate with the other Hyper-V virtualized machine, the VM host and the internet. So click next, then 25, then click next, then step 10. Select the radio button next to the install an operating system from bootable image file, then select browse. Then step 11, double click the documents folder, double click on module 7 folder, and select the Ubuntu 22.04.3 desktop MTOs and then click open. The selected ISO file is an exact copy of the installation CD-ROM or DVD. Loading the ISO into the machine enables the Ubuntu OS to install. So click next, then click finished, then right click on the Ubuntu 22.04.3 VM and select setting, security, and then hardware pane. In this hypervisor environment, secure boot will cause a conflict, so it is disabled before starting the machine and continuing with the installation. So deselect or on ACI Win11 window, deselect the enable secure boot checkbox on the security pane, then click OK. So task 2, launch Ubuntu installation. So ACI with the Hyper-V Manager windows open, right click on the Ubuntu 22.04.3 VM and select connect. Through Hyper-V, a turned off VM can be connected, after which can be started. So click start, then click maximize icon, then press enter to install Ubuntu. Then welcome page, clicks install Ubuntu, then click continue, Then untick the download updates while installing Ubuntu option. Click continue and click install now. You click continue, another click continue. Then who are you? Page populate the following fields. So ACI admin, choose password, and then confirm your password. And then step 11, process begins. Ubuntu installation process begins. Note, this initial installation steps takes approximately 21 minutes to complete. While this is securing, continue to exercise 2, then you will return to the ACI Win11 device to conduct the final configuration of the Ubuntu machine in exercise 3. So click next. Exercise 2, use containers. Both virtual machines and containers can be used to run application and workloads on a single physical machine. But there are significant differences between the two. VM providers provide a higher degree of isolation through the hypervisor. Containers have significantly less resource overhead because they shared the host OS kernel rather than making their own copy of the OS kernel, like a VM does. Container also boot notably faster than VMs because they don't need to boot their own OS kernel. In this exercise, you will explore how to create and manage containers from both a CLI or command line interface environment and GUI or graphical user interface environment. So, learning outcome. After completing this exercise, you should be able to create and manage containers from CLI, create and manage containers from GUI, and your devices will be using the following devices in this lab. Please power this on now, ACI DC01, ACI Win 11, ACI Kali, then task 1. So create and manage containers from a CLI. Docker is a container engine. It is used to develop, deploy, and run containers. Docker is available in both Linux and Windows. In this task, you will create and manage containers with Dockers in a Linux command line. So connect to ACI Kali, then select the Terminator emulator, then in the terminal emulator, tap the following and press enter. Sudo docker pool hello world. Then note, the docker pool command is used to download container images from a container registry. In this command, the registry being used is Docker Hub. The downloaded image contain everything needed to run the application or conduct the function they are designed to conduct. All code dependencies, libraries, and runtime environment are included in the Docker image. So sudo docker pool hello world password. So in the terminal window, type the following and press enter. Sudo docker images. Note, observe the hello world image has been downloaded. The hello world container is used to verify that Docker is correctly installed and working. So type the following and press enter. So sudo docker run hello world. So note, the docker run command is used to create and start a new container based on the specified Docker image. In this case, the hello world image. So type the following and press enter for step 6. Sudo docker run -it ubuntu bash. So note, as recommended by the Hello World container, this command pulls the latest Ubuntu image from the repository and runs it all in one command step. Using the -it switch with the docker run command starts the Docker container in an interactive mode, allowing the user to interact with the container. In this case, the interaction occurs through a bash shell. So who am I? Enter. So note, the Kali Linux purple user is ACI admin. The whoami command is being run in the Ubuntu machine command line as the root user. So ls. So step 9, exit. So the exit command exits the interactive interface to the container and returns control to the host terminal. So in the terminal window, tap the following and press enter. So sudo docker images. Observe there are now two images that have been downloaded, Hello World and Ubuntu. So step 11, sudo docker ps. So note, observe that there are no images currently running. So step 12, sudo docker pull CentOS 8. So note, the command pulls the CentOS Linux image from the repository. So in the type the following and press enter. So sudo docker images. Then step 14, type the following and then press enter. So sudo docker run -d name my CentOS -it 5d0 ta 3ds 9764. So the last number is the command is the in the command is the CentOS Docker image ID. This may be different in your machine. Type the CentOS Docker image visible from the Docker image command. The previous step. So note, instead of referring to the images only by the image ID, the dash name switch can be used to provide a plain text name for the image that can be used in future commands. In this command, the name myCentOS is bound in the myCentOS image ID. So tap the following and press enter. Sudo docker ps. Now it is now confirmed that myCentOS OS has been assigned in the name myCentOS. So step 16, sudo docker exec -it myCentOS bash. So note, an interactive shell can now be established with the CentOS container using with this the myCentOS name rather than the image ID number. So who am I? Notice the interactive shell is running on the CentOS container. Then ls. Then at the root prompt, they are following. Type the following, then press enter. Then in the terminal window, type the following and then press enter. Sudo docker ps. Then since the myCentOS container was manually restarted, even after it exited, the process and container still exists even without the interactive connection. So sudo docker stop my CentOS. So the Docker stop commands stops a running container, gracefully terminating it. So leave the terminal emulator open, create and manage container from a GUI. Portainer is an open source container management platform that enables the creation and management of Docker containers. In this task, you will install and use the Portainer container. Step 1. Ensure you are connected to ACI Kali and the terminal emulator window is open. So in the terminal window, type the following and press enter. So sudo docker volume sudo docker volume create Portainer underscore data. So Pioneer date. So the pointer application requires a volume to store data and configure files associated with it. This command creates the volume. So in the terminal window, type the following and then press enter. So sudo docker run -d -p 8000 8000 -p 9443 9443 /name partitioner restart equals always -v partitioner underscore data /data partitioner slash partitioner or partiner -ce latest. Then click enter. So note, this command pulls the partitioner image and binds the browse interface to port 9443. It also aligns the previous partitioner data volume for use. So terminal window, type sudo docker docker ps, then press enter. Then step 4, sudo docker ps-a, then hit enter. The -a switch on the docker ps command shows running and exited containers. So in the terminal window, type the following and press enter. So Firefox https //local host 9443, enter. So this command starts Firefox and connects to the Portainer application in port 9443. Then the Firefox select advanced. Then accept the risk and continue. Then type the following into the password and confirm password. Then create user. Save login. Then don't save. Then select get started in the environment wizard pane. So select the local panel in the home page. Select images from the Partainer.io pane on the left. Observe that this is a much simpler interface to observe than the Docker image command output. So in Partainer, select containers from the Portainer.io pane. This page shows the same data as the Docker ps-a command. So step 14 in the container list pane, scroll right to the containers menu and select add container. A new container can be pulled and created from the GUI with the add container button. The container in the create container pane, type the following in the name field: my Kali Linux. In step 16, create container pane, type the following to the image field: Kali Linux slash Kali dash rolling. So Kali rolling is a tag version of the Kali Linux repository image. So scroll down in the advanced container setting, select the radio button next to the interactive and TTY for the console field. In order to interact with the new Kali Linux container, an interactive and TTY container needs to be defined. So step 18, in container, select deploy the container. So step 19, once the deployment is successful in container in the container list pane, select attach console on the running my Kali Linux container. So note, a command line interface can be achieved with the running container through the attach console option. In Portainer, in the attach pane, type the following and press enter. So who am I? Then type the following and press enter, ls. In attach pane, select detach and select containers from the Portainer.io pane. Then in the container list pane, tick the My Kali Linux container checkbox. In the container list pane, in the containers menu, select stop. Step 24 and 25 conduct the same action as the docker stop command. So once the container is successfully stopped in Portainer in the container list pane, select logs from the Portainer container. So close the Firefox window, then close the terminal window, and exercise 3, complete VM deployment. Once a VM has been created and the ISO file has been applied, the operating system can be configured and run on the first time. In this exercise, you will complete the Ubuntu VM deployment in Hyper-V. So learning outcomes: after completing this exercise, you should be able to manually relaunch the Ubuntu VM, test the new VM. You will be using the following devices in this lab. So please power this on now: ACI DC01 and ACI Win11. So task 1, manually relaunch the Ubuntu VM. In order to continue VM deployment, it must be relaunched. So in this task, you will manually relaunch the Ubuntu VM so it can be configured and run for the first time. Connect ACI Win11 where the Ubuntu 23.04.3 on ACI Win11 VMW is open. Once the installation is complete, click the restore down icon at the top of the window. Then select the action menu and then select turn off. Then select turn off again. Then select start. Leave the ACI Win11 device in its current state and proceed on the next task. So next task, task 2, test the new VM. When a VM OS is run for the first time, there is a minimum amount of configuration that is required. In this task, you will configure the Ubuntu VM for the first time and test a deployment. So step 1, connect to ACI Win11. Click the maximize icon on the Ubuntu 23.04.3 on ACI Win11 on the device restarts. In the Ubuntu 23.0.3 on ACI Win11 window on the connect your online accounts page, select skip. Then enable Ubuntu Pro page, click next. Then help improve Ubuntu page, select next. Then next again, and then lastly step 5, you're ready to go page, select done. So in the server update pop-up, select remind me later. Note, depending on your timing in the lab, this window may show up here or during the new next few steps. So step 7, In the Ubuntu VM desktop, select the Firefox web browser on the left pane. In the Firefox, type the following into the URL field, then press enter. So duckduckgo.com. So step 9, close Firefox on the Ubuntu VM. Then step 10, on the Ubuntu VM desktop, right click and select open on terminal. So in the terminal window, type the following and press enter cd. Then step 12, type the following and press enter ls. So close the terminal window. In the Ubuntu VM, select the power icon in the upper right corner of the screen, then select power off or log out. So in the Ubuntu VM, select power off and power off pop up. So step 17, in Ubuntu 2022.04.3 on ACI Win 11, select file and exit file. So close the Hyper-V Manager window. So keep all devices that you have powered on in their current state and proceed to the review section. So review. Well done. You have completed the Security Architecture Models Practice Lab. Though not the only security architecture models, VMs and containers are important to an enterprise network and provide efficient resource utilization, scalability, portability, and flexibility to the enterprise infrastructure. So summary, you completed the following exercise. Exercise 1, create a VM. Exercise 2, use containers. And exercise 3, complete VM deployment. So you should now be able to create a VM in Hyper-V, launch Ubuntu installation, create and manage containers from a CLI, create and manage containers from GUI, manually relaunch the Ubuntu VM, and lastly, test the new VM. So submit feedback. So shut down all virtual machines used in this lab. Alternately, you can log out on the lab platform. So log out. Finish.